Hey, so we're going to talk about matched pairs, okay, and do a little introduction to matched pairs. There's a couple different ways you can do matched pairs. Matched pairs is a form of blocking, okay? It's a form of a randomized block design. One way to do it is like a before and after, okay? Where you're doing two treatments on one unit, okay? Two treatments on one unit. We'll say that's number one. Number two, you compare two treatments on two very similar units. Okay, because you can't always do it on, two treatments on one unit, and I'll explain some examples in a minute. Okay, so let's do this first one. Let's concentrate number one. Two treatments on one unit. All right. So we'll do the before and after. So before and after would be, let's say you had 3 astronauts. Okay, and you wanted to see if space travel affects someone's white blood cell count. Does space travel affect someone's white blood cell count? Okay, that's the question we have. So you take the astronauts, you measure the white blood cell count, okay, send them up into space, okay, and then when they come back, you measure the white blood cell count again. Okay, they're matched pairs. The person's being matched with themselves. Okay, you measure the white blood cell count, you do the experiment, you measure the count again. Okay, and that's probably the best way, because if someone has a high white blood cell count, or low, whatever, but you're doing it with the same person. Okay, so if it's the same person, it's easy to see the difference when you send them into space and they come back and you measure it again. All right, one way. That's one way. Okay. Same thing. We'll concentrate on that same one. Let's say there's 100 subjects, okay, and we want to test a new mosquito repellent with an old mosquito repellent. Okay, so let's look at the different ways for this. Okay, let's look at all the different ways. You have this bin, right? And in this big bin, they put all the mosquitoes in there, and then these 2 holes in the top. Okay, so to do completely randomized, we'll go through the different types. Completely randomized, you take 100 people, you give 50 the new repellent, randomly take the other 50 and give them the old repellent, have them put it up, slap it all over their arms, go to the box, stick them in, then pull the arms out and just see how many bites they've got. Okay? The problem is, some people are much more likely to get bit by a mosquito than others. Okay, some people go outside and they come in, they've got like 7 bug bites, and someone else has been out with them and they don't have any bug bites. So there could be something with like skin tone or something like that. So this probably isn't the best way to do it. Okay, so to do a matched pairs for this, okay, to do a matched pairs, what we could do is you take one person and on their right arm give them the new repellent, and then on the left they get the old repellent. Okay, or what would be a better way is you take the one person and you flip a coin. If it's heads, they get the new repellent, and if it's tails, then the left arm gets the new repellent. Something like that, okay? Because you want to randomly choose which arm gets the new repellent, okay? But by having the same person, you're gonna be able to measure it better. So that's matched pairs. You've matched that person with themselves. Okay, it's one arm, one arm. It's just the same person. All right. Again, heads or tails. Heads, new repellents on the right arm. Tails, the new repellents on the left arm. Something like that in terms of setting it up. Okay, but that's an example of matched pairs. Taking a person, matching it with themselves. All right. So then the other one was when you match people as close as you can together. Okay. Before you do something. So let's say we're trying a sunscreen. Okay, and it's a new, again, versus old sunscreen. Well, you can't take a person and split them down the middle and have their left side of their body be a new sunscreen and the right side of their body be an old sunscreen. Just doesn't make any kind of sense. Okay, so let's say that it is widely known that age is a factor to how people tan or say burn. Okay, and so we had all these people, and these are the ages of the people that are going to participate in our study. 19, 25, 50, 22, 27, and 55. So what we might do is we might match people of similar age. Okay, so we would take the 50 and the 55-year-old. Okay, so we'll take the 50 and the 55-year-old, and they'll be in one group. And then we'll take the 25 and the 27-year-old, and they're in another group. And then the last group would be the 19 and the 22-year-old. So we're blocking. It's a type of blocking, but we're matching them with someone that's that are close in age. And the reason we're doing that is because we knew ahead of time that age is a factor in how people tan or burn. Okay? So then what we do is you flip a coin or something. Okay, flip a coin and randomly give one the first one. So you say, if it's heads, the younger person gets the new sunscreen. If it's tails, the older person gets the new sunscreen. Okay, and so you go through here. This one was A and B, and then this one ended up being B and A, and this one ended up being A and B. Okay, and then you compare your results. Okay, so you need to, all the things that I'm saying are things you would need to write down. Okay, but I'm just trying to show you how you could do it. Okay, one last example with matched pairs would be like if you had plots of land. Okay, and you've got these plots of land and you want to see how fertile the land is. Okay, and so we've got one, two, three. Okay, so we've got all these plots of land, and we want to see how many tomatoes we can grow in these different plots. So the experimental units are going to be the plots of land. Okay, because that's what we're trying to measure. We're trying to see if some plots are better than the others. Okay, so we could randomly just put like A, B, A, B, A, B, A, B, but based on what's near these plots of land, there could be water or there could be trees, or we don't know. So to do matched pairs, you could take each plot of land. So there's 1, 2, 3, 4, 5, 6, 7, 8. Okay, you've got these plots of land. Okay, and you could take the plots of land and split them out in half. Okay, so you could split this in half and split this plot in half and split this plot in half and split this one. And when you split those plots in half, you could flip a coin and you could put you could put plants, break it up, put A then B, or then this one ends up being B then A, and the way you are determining that is by chance, something randomly, flipping a coin or something like that. But by splitting the plots in half, you're taking that one plot and you're splitting it in half, and then you're putting your different treatments in those plots, okay, or your tomato plants in those. You're randomly putting plants into these plots of land, okay, and then you're going to measure what happens after you perform your experiment, whatever that might be, okay. So that's another example of matched pairs. We took the unit, we took the thing that we were trying to measure, the experimental unit, and we split it in half, okay, and we put one thing on one side and one thing on the other, okay, together. Matched pairs, you match two pairs together, okay. So let's see if we can get through the rest of this here. What do I got left? Oh, that's it. Awesome. So actually there is something there, we don't have to do that. Homogeneous groupings means having similar or uniform characteristics. A community where most members share similar characteristics, that's homogeneous. So that's like, homogeneous would be like in school if you were grouping and you put like, AP statistics is kind of like a homogeneous group because they're usually stronger students in there. And then some classes are not homogeneously grouped, like maybe gym class. Gym class, you probably just have a random scatter of students. You have some people that are really good students and you have some other people that struggle. So that would be an example of a heterogeneous group. This mixed group has different ages. You might have different ability levels in there, but a homogeneous group is something that has, you know, some kind of uniform characteristics. All right, here we go. The final pieces here. Final pieces of this section. So this is extra stuff that they added into the course last year, so it's important that we go through it. Observational studies, retrospective and prospective. Okay, we did talk about that already. Sample surveys are a kind of observational study. Okay, let's see what else it says. Observational studies examining existing data are called retrospective. So it's data that's already happened. Observational studies that track individuals into the future are called prospective. Okay, so on the back of this, we'll go over this in class. You guys have to remind me when we go through this. All right, so I want you guys to read this and then we will go over the answers in class. Do them. You guys got to do them. Do them as part of your notes and then we'll talk about them later.